Hello, and welcome to my presentation about open source firmware status on AMD platforms 2022 on open source firmware BMC and bootloader devroom on 2022. My name is Michał Żygowski, and I'm a firmware engineer at FreeMDep. I'm mainly interested in open source firmware, advanced hardware and firmware security features. I maintain Braswell SoC PC engines and protect the platforms and coreboot. I'm also Open Power System Software Technical Workgroup Chair. I am nearly 4 years in the open source firmware ecosystem. Who we are exactly? FreeMDep is a coreboot licensed service provider since 2016 and UEFI adopter since 2018. We also are Yocto participants and embedded Linux experts since 2019. We of course provide official consultancy services for Linux Foundation FWPDLVFS project since 2020. We are also IBM Open Power Foundation members since 2020. A few definitions that I will use across this presentation. AGESA, which stands for AMD Generic Encapsulated Software Architecture, pronounces somewhat like PISA, AGESA. It is a processor initialization code supplied by AMD to BIOS vendors. Can easily call it an FSP equivalent, but for AMD. However, it requires NDA and sometimes special relations to get your hands on it. Well, despite it being compliant with UEFI interface, it does not support open source toolchains like GC or LLVM. If you want to know more about AGESA history, please refer to our presentation from fall 2020, where I talk a little bit more about its evolution. AMD Security Processor, commonly referred to as PSP, so Platform Security Processors. It is an AMD equivalent to Internal Management Engine. It's also a coprocessor, but it lives on the CPU instead of the chipset, and it is performing a similar operations to Intel. Some security, cryptography, CPU bring up as well, and stuff. There are also a lot of processor code names and architecture names, which may be found on Wikipedia and cpuworld.com. And I will go briefly through the ones that will be mentioned during the presentation. We have a few of the names like microarchitecture names and core architecture names. For example, Puma is a Step Eagle core architecture. Embedded SoCs, which are, for example, used on PC engines APU2. Bulldozer and PileDriver are, for example, server processors based on Intel Lagos or Abu Dhabi core architecture, which are used, for example, on KGPE-D16. PileDriver is also a microarchitecture name for Trinity core architecture processors, which are mobile APUs, which are, for example, used for Lenovo G505S. And we have all the modern Zen microarchitectures called Picasso and Cezanne. These are Zen Plus and Zen 3 core architectures with Ryzen 3000 and 5000 series. Cezanne is pretty new in coreboot, and recently we have also may find Sabrina processors, which are being added in coreboot. However, there's not much information about them yet. All we know that it is family 17H models, which vary from AO hex to AF hex. So a short recap from last year about the new platform support in coreboot. There were two microarchitectures being added by AMD. It is Picasso and Cezanne. These are the mobile processors that are used on the Google Chromebooks. Picasso was already pretty much complete last year in 2021, and now we have almost complete AMD Cezanne support, which initial patches were issued last year. There was also the AMD Majigla reference board support added, and everything took a lot of time because of the groundbreaking changes to the architecture. I am specifically referring to the run training, which is done by the AMD PSP now, and the cores which actually leave out the reset with the RAM already available. So today's status is that the Picasso and Cesian are complete and usable, although the Cesian FSP is not yet published. There are also some other patches that, for example, implement BIOS A and B partition recovery and an AMD FW tool, or PSP firmware extraction, AMD FW tool. A similar functionality is provided by the PSP tool, which was developed over 1 year ago by PSP Reverse team on GitHub and published and announced on Chaos Computing Conference. There are also some first patches for Sabrina SoC, as I mentioned, which you may find under these links. The past year was rather more on negative side than on positive regarding the older AMD platforms. You may see coreboot mailing list threads or leadership meeting minutes for some evidences. I will also be covering this topic in next slides. Okay, regarding the AMD server status. In 2021 on Open Source Firmware Conference, Ron Wennig from Google presented an pure open source firmware on AMD Epic ROM system server board, which were running oreboot, written in Rust, and he managed to build Linux kernel using his implementation. And of course, we had some rumors that there is a chance that AMD servers will also get some open source firmware support. However, no updates about it up to date, unfortunately. Neither on the oreboot implementation done by Ron. The last issue was that the I/O devices were not initialized correctly, so it was unable to boot from any storage media. And of course, it has not been resolved yet. You may also visit the open source firmware Slack channels. You can find there some concerning information about AMD open source firmware support on servers. How the future will shape the AMD open source firmware. In 2021, we had pretty much a negative attitude to the old AMD platforms. Many platforms have been dropped from the tree. There are also a lot of complaints on the code quality. There are many copy-paste code in the repository. The official explanation of coreboot leadership, why the code ended up in such state, is that this code was landed in without much review, and AMD was supposed to clean up this code base. However, these promises haven't been fulfilled up to date, so this is why it ended up in such state. And nowadays, new coreboot releases come with new feature and options deprecation announcements. These announcements just say which coreboot interfaces will be deprecated, which will be removed from the main tree. And many older AMD platforms which did not implement such new interface for platformization or options, as a result are of course getting dropped as well. But thanks to the companies like PC Engines, who support the open source firmware development for FreeMDEV, some of the platforms still keep living in coreboot. For example, we have Family 14, which supports APU1 devices, and the support for the newer interfaces is in review. And for Family 16 binary PI, which is used for APU2, the support is already upstream and the platform won't be dropped for over half a year from now. The Trinity and KBNI, which is Family 15 and D16 open source AGESA platforms, they still lack support for these interfaces, and we welcome any donations if you want to have them supported. Donations, I mean, maybe material, maybe hands, or testing or development, anything. We can also help with review if you upload some patches. The future of modern CPUs also is quite dark, because recently we have sightings and reports that newest firmware on the AMD processors is enforcing the CPU lock. The CPU lock is related to enabling platform secure boot, which is an equivalent of Intel boot guard but on AMD processors, and it binds a certain platform key to the CPU. Because of that, such CPU cannot be used in another platform with different firmware key if it was already fused. Because it's a serious vendor of lock-in, which steals the user's freedom of firmware modifications and stuff. So for example, if one wants to patch some firmware modules that would change the CPU allow list or any other hardware allow list or freely placed CPUs, it is no longer possible because you may end up with a locked CPU or just buy a locked CPU and cannot simply put it. This situation is much different from Intel because Intel BootGuard fuses the chipset. So the CPU is still replaceable, but you cannot simply run other firmware, right? And for example, such a setting you may find on the link that some Lenovo machines automatically locks the CPUs. And they display a screen to lock the CPU on each boot until you agree. However, there is some ray of hope with Dasharo. Dasharo is a FreeMDev open source firmware distribution where we prefer some clean and simple code and long-term maintenance also for older platforms. We want to respect privacy, liberty of the owners, and trustworthiness of all. And as a sample of such implementation is the ASUS KGPE-D16 revival, which has been sponsored by Immunify. It is one of the most performant and most recent truly blobless and library hardware, which was certified with Free Software Foundation Respect Your Freedom. The hardware was donated to us by Vikings, which were also distributing this hardware for some time already. And our main goal of Dasharo on this platform is to provide some ready-to-flash binaries for various configurations of the platform. The coreboot on this platform is based on middle between 4.15 and 4.14 release. It currently complies to all most recent coreboot requirements and thus could not be dropped because of these requirements. We plan to upstream the code soon to the main tree. So a little bit about the sponsor. Immunify is a leading bug bounty and security service platform for Web3. Their goal with KGPE is to have a secure and trustworthy machine for the blockchain developers. This machine is widely used by Immunify and Free Software Foundation as well. In short, what we did for this platform was to rebase the old code onto the newest coreboot source that were available on main branch and make it boot. Furthermore, we improved the security by implementing vboot support and TPM 2.0 support for the board. The scope of the project also involved additional work related to flash write protection support in FlashROM, so that we can, for example, using a user space application such as FlashROM to configure the block protection on the SPI flash and set some write protection for the status register, for example, for platforms that may use some write protection pins. We also did some small modification to the flash because by default this platform uses a DIP8 flash, which is a 2 MB flash. For nowadays it is pretty small, and we decided to provide a means to use a bigger flash with SOIC 8, for example, socket. So we provide some adapter that will have a SOIC 8 flash soldered on the adapter, and we put this adapter into the DIP8 socket. We also modified the adapter in such a way that it exposes 2 pins for a write protect pin jumper, so that one may provision a static root of trust for measurement using an immutable piece of code inside flash. This is for KGPE, but there are also other platforms that are pretty similar in terms of used code and architecture, and I mean specifically the ASUS KCMA-D8 and Supermicro H8 SCM. They use the same common silicon initialization code as KGPE-D16 and are also blobless platforms. Have not implemented the support for them because we do not own any hardware. So if you want to get the support for these platforms, please feel free to donate. It may not only be some financial donations, but also hardware or hands to work or test as well. We will present the Dasharo plan for the long-term stable and sustainable support for other platforms soon. If you want to know more about the recent news and information about the supported platforms, please sign up to our Dasharo newsletter. Also, I invite you to our after hours party, which will be held right after the end of this dev room. We will discuss more about the open source firmware and its ecosystem in general. Also, we plan to hold the Dasharo VPUB 4th edition on the 17th February. We will be discussing also open source firmware topics and other stuff as well. So please book your time and come discuss with us. And time for questions. Thank you.